Have you ever stopped to think about what's actually happening when you talk? I mean, really think about it. It feels so simple, but underneath, you're running a massively complex system without even trying. Today, we're going to pull back that curtain and look at the hidden science behind your own voice. So, let's get into it.
Everything we're going to talk about starts with a really simple question. What's the real difference between the words pat and bat? Now, you might be thinking, it's one letter, a P and a B. And yeah, you're not wrong, but the real answer is so much cooler, and it's happening inside your body every time you speak.
You see, on the page, it's just B versus P. But in the world of sound, what linguists see, it looks more like this. It's a tiny physical difference in how we make the sound. And that one little distinction, it's the key that unlocks the entire science of how we speak.
All right, to crack this case, we need the right tools. And in linguistics, that means two core sciences, phonetics and phonology. They sound kind of similar, I know, but they give us two totally different ways of looking at the same thing, sound.
Here's the easiest way to think about it. Phonetics is the how. It's the raw physics and biology of making a sound, any sound. Phonology, on the other hand, is the why. It's about how a language, like English, takes those sounds and organizes them into a system to make meaning. One's the raw material, the other's the architectural blueprint. So if we zoom in on phonetics, it all starts with articulatory phonetics. This is just a fancy name for the mechanics of speech. It's all about how your lips, your tongue, your throat, all those parts move to shape the air coming from your lungs into a specific sound. This is literally the making stuff part.
And on the flip side, you've got auditory phonetics. So, once a sound is made and it travels to someone's ear, what happens then? Well, this field studies how our ears pick up those sound waves and how our brain decodes them. This is the hearing stuff part of the equation.
And what connects the two? Acoustic phonetics. This is the pure physics of the sound wave itself as it zips through the air between me and you. It's like an invisible bridge. Now, for our pat versus bat mystery today, we're going to focus mostly on that first step, the making.
So, let's pop the hood and take a quick tour of the incredible sound-making factory that you carry around with you all day, every day. Every sound you make, from a whisper to a yell, basically comes off a four-step assembly line. First, your lungs provide the power, the airflow. Second, that air travels up through your larynx, or your voice box. Third, it's shot into your mouth or your nose. And finally, number 4, your articulators, that's your lips, tongue, and teeth, do all the fine-tuning to shape that air into a recognizable sound. Using this system, we can create a sort of recipe for any consonant. So let's go back to the P sound in pat. Its recipe has 3 ingredients. First, its voicing is voiceless, meaning your vocal cords don't vibrate. Second, its place of articulation is bilabial, a fancy term for using both lips. And third, its manner is a stop, which just means you stop the air for a split second, then release it. Pa. Okay, now let's look at the recipe for the B sound in bat. Let's compare. Place, it's bilabial, uses both lips. Check, just like pa. Manner, it's a stop, air gets blocked. Check, just like pa. But, the voicing? This is different. For the B sound, it's voiced. Your vocal cords are vibrating. And boom, there it is. We've solved it. The entire physical difference, the secret ingredient separating pat and bat, is just that tiny vibration in your throat. That's it, the presence or absence of a buzz. And hey, you don't have to take my word for it. Let's do a little experiment right now. Seriously, put your fingers on your throat. Now make a long B sound. Feel that little hum? That vibration? Okay, now do a p sound. Nothing, right? It's just a puff of air. You just felt the science of phonetics right there on your fingertips. So we've figured out the how. The physical difference is a simple vibration. But that just leads to a bigger and frankly more interesting question, the why. Why does that little buzz matter so much? And for this, we have to switch from the raw materials of phonetics to the grand blueprints of phonology. The answer comes down to this absolutely crucial idea, the phoneme. A phoneme is the smallest unit of sound in a language that can actually change the meaning of a word. You can think of it like an atom of meaning. They're the basic building blocks your brain uses to sort and understand every word you hear.
And this is where it all clicks into place. The sounds B and P are 2 different phonemes in English for one simple reason. Swapping one for the other creates 2 totally different words. That one little vibration is the only thing standing between a furry, flying mammal and a gentle tap on the shoulder. It's not just a different noise, it's a completely different idea. And that is the incredible power of phonology. But here's the plot twist. All these clean, tidy rules work perfectly when we're saying words one by one. But nobody talks like that, right? In real, everyday, fast speech, our mouths start taking little shortcuts and the rules start to bend. One of the most common shortcuts is something called assimilation. This is basically your mouth being super efficient. To make saying two sounds in a row a little easier, your mouth will actually change the first sound to get ready for the sound that's coming right after it.
For example, just take the word input. We spell it with an N right there in the middle. That's the correct formal way to write it and how you'd say it if you were being really careful.
But just say it out loud quickly. In a sentence like, I need your input on this. You probably say input. So why does the N sound turn into an M sound? Well, think about it. The P that comes right after it is made with your lips. So your mouth just plans ahead and makes the sound before it also with the lips. It's a tiny life hack for lazy talking.
And you know what? Sometimes our mouths are even lazier. They don't just change a sound, they delete it entirely. Just poof, gone. This little shortcut is called elision. It's when we just drop a sound that's written on the page.
A perfect example is the word friendship. I mean, look at it. There's a D written right there. But when was the last time you actually heard someone pronounce it? Friendship. Pretty much never. We all just say friendship. The D sound vanishes, just to make the word flow a little better. It's a ghost letter. You can see it, but you can't hear it.
So let's just step back for a second. In just the last few minutes, you've learned that speech is a physical machine, that languages have an organized sound system, that we build all meaning out of these tiny little sound atoms called phonemes, and that in the real world, we all bend these rules constantly. Pretty incredible, right?
And all of this leaves us with one final kind of mind-blowing thought. You do all of this, vibrating your vocal cords just right, placing your tongue perfectly, changing sounds, deleting others. You do it thousands of times a day, instantly, without ever having to think about it. This huge, complicated system just works. So the real question is, who or what wrote that rulebook?